All right, so this is going to be the Unit 11 review number 12 and 13 is what we'll do in this video. Um, I, you may hear a bunch of purring because I have a cat sitting in my lap, just so you know. So, okay, so the first problem is asking us to figure out what AC is. First, this thing is a rectangular box, so all angles that look like they'd be right angles are. Um, this thing on the ground here, that's actually a rectangle. If you looked at it directly, it would look like this. Here's A, here's C. So this would be the bird's eye view, right? The 15 would go right there, and this would be a rectangle too. So you kind of have to realize this is a 3D picture, and that's a rectangle. This face right here is a rectangle. The top's a rectangle, etc. Right? They're all made out of rectangles. So let's see. Find the length of AC. So notice we got this blue triangle ABC built into the shape, and there's a 63 degree angle up at the top. Let me call AC X. So if we used opposite and adjacent, which is tangent, we can say tan of 63 is opposite over adjacent, x over 10. So then if I multiply the 10 over, we'll get x, and if you plug that into a calculator, you end up with x being 19.62611. And that's the same thing as AC. So 19.626 if we round to 3 places. So let's see if I can shrink this down a little bit. All right. So right here, I'm going to put right here 19.62611. All right. The next part says figure out what the total area of the box is. So that's all 4 sides of the box, plus the top, plus the bottom. So we got 6 rectangles we need to add together. Well, notice since the height is 10, this length here is 10, this length here is 10. So 2 faces should be easy. The face right here on the right, and then the one that's kind of tucked in the back here, the face on the left, should be easy. Those are both 10 by 15 rectangles. So I'll write here the area of the, let's say the left face of the box equals the area of the right face of the box, which equals 10 times 15. So that's 150. So the left is 150, the right is 150. The front of the box, this part right here, right, whoops. Well, anyway, the front of the box, we know it's 10 by whatever this length is. So we got to solve for that. Now notice AC we already figured out. This is the base of the box here, right here, the green rectangle that I drew in. So this part right here is 19.62611. And if I knew what this was, right here, well, I'll call that y. Then I could figure out 10 times y would give me the front of that box. So let's figure out what y is by using the base, and we can do Pythag. So 15 squared plus y squared is going to be 19.62611 squared. And you should still have this stored from before. So if I do y squared equals the 19.6 squared minus the 15 squared, I end up with 160.1839996. Then if I take the square root of that, it's 12.65638. So that's this length right here, 12.65638. So at this point, I can now figure out the front of the box. The area of the front is going to be the same as the area of the back of the box. So it's going to be 10 times y, which is the same thing as just moving the decimal over by one place, so that's going to be 126.5638. So that's the front of the box, and it's also the back of the box. So we've got one other thing left. We need the top and bottom of the box. Well, here's the bottom of the box right here. That's just 15 times y. So the area of the top is also going to be identical to that. So it's 15y. And if we type that into a calculator, we would end up with 189.8457. And so the total area here, if I take these guys, so total area is going to be 2 of the 150s, because there's one left side and one right side. And this isn't all going to fit. Plus 2 of the front, or one front, one back, but it's 2 126s. And then plus the top and the bottom, which is 2 times 189.8457. And so if we add those all up, we end up with 932.819 if we round to 3 places. And I don't think there are any units for this. It would be units squared because it's an area. Okay, so I hope that helps a little bit. And then let's try 13 also. So 13 is a rhombus problem. So let's go ahead and just sketch a rhombus out here. So here's the rhombus. One of the diagonals is 30 inches in length. So let's say that's 30. The total area is 240. I'll draw on the other diagonal too, because we know that these are perpendicular. We end up with 4 congruent triangles. The 30 gets cut in half into 15 and 15. And since the area of the rhombus is 240, I just cut it into 4 congruent triangles. So the area of one triangle is 1/4 of that, which is 60. So we need the other diagonal. So I'm going to call one part of it x. So I'll double it once I solve for x. So the area of a triangle is 60. I also know the area of a triangle is 1/2 base times height. And the base of my triangle is 15. The height is x. So now I can solve for that. If I multiply both sides by 2, I get 120 equals 15x. And if I divide both sides by 15, I get 8 equals x. And I really want 2x. So 2x, diagonal is 2x, which is 16. And it would have to be in inches. So it's going to be 16 inches. Okay, so I hope that makes sense.